I'm Sharon, working as assistant professor in St. Joseph Institute of Technology. So in today's video, we are going to learn about restoring division algorithm. Over here in restoring division method, you have two types of division part. One is your restoring and the other one is your non-restoring division. So in future other steps, we'll be learning about the workflow diagram, like how you're going to solve your architecture diagram in restoring part, where in binary numbers, how you're going to calculate it, and the division part, all those things. So here the workflow diagram represents, so in the initial step we're going to start your procedure, and the next one you have 4 registers. One is A, is going to be your initialization value, and similarly your M is going to be your divisor part, and over here Q is going to be your dividend part, and similarly N is nothing but the count of iterations you're going to occur over here. So in this initialization process will be your 4 registers. So one register is A and the other register is M is your divisor, as well as Q your dividend, and the 4th register is count the number of iterations you're going to occur. And over the next step you're going to identify the condition over here, giving condition as shift left of AQ. So while assuming my variable initialization procedure, I'm going to give the condition as shift left AQ. So whatever the divisor part as well as my dividend part, what I'm going to shift over here. Whereas in previous video, multiplication part we want to shift it in your right shift operation. Whereas it comes under your division part, you're going to do your left shift operation, identifying my shifting my operation to my most significant bit. And next goes on to the next step is A is equal to A minus M. Over here, divided your A value initialization as well as my M or the divisor value, you are going to assume it as M value will be declaring. When it comes under my minus M, I am just giving it as 2's complement method. So similarly, I'll be adding my condition, my initial variable A as well as M value. I'm going to check my sign bit of condition. If my sign bit of the A or the particular value, if it is sign bit is 1, I'm going to write my Q naught value as 0, and similarly restore the previous A procedure step. Where when the sign bit is 0, I'm going to condition for the value as Q naught is equal to 1. So over here, when completing this, I'm going to decrement each value. So for the first iteration, what are the value? We're given it as N is equal to 4 or N is equal to 5. I'll be declaring it and giving it as decrement N. So for each procedure, for increment for each iteration, it is going to decrement each value. So when it gives a N minus 1, goes on to my 3, then second step and 4th step, and all those things until my value gets N is equal to 0. So when my count register becomes 0, I have to supposed to stop my condition. So I'll be improving my quotient and my remainder value over here. If it doesn't get solved, I'll go on back to my initial procedure. After my initialization, goes on to your shift left AQ. So this is going to be your flowchart of my restoring division part. So in this example part, I'm going to give it as, I'm giving a simple example as 11 divided by 3 using as a restoring division algorithm. So while solving your division part, I'm going to handle my binary numbers over here. So in binary numbers, I'm declaring my 11 binary number as well as 3 binary number. So here 11 is going to be 1011. That is my Q value represented as dividend over there, and 3 is gonna be my divisor over here, Z0011. Okay, so here my value is 11 and Q 3 is gonna be M value, and A is gonna be my initialization value, which is A is equals to, it is gonna be 0, 0 and 0. So while starting my procedure, I'm supposed to declare it as, if it is like I'm having it as 4 bits, so my dividend value is also 4 bits as well as my divisor value is also 4 bits. So while declaring my initialization part, I'm supposed to add one more 0. So every time if it is 4 bits, my A value should be 5 bits. If suppose my question is something like divide 25 divided by something number, if it is in 5 bits or 6 bits, my initialization A value should be another plus 1. If my initial number should be in 5 numbers, means it's A bits should be in 6 bits of representation. Okay, so we'll be looking on to the problem sums. So we are continuing about your flowchart of your restoring division part. So here when you come into your problem, we are taking up example part as 11 divided by 3. So here when taking 11, as a binary number is 1011, and as well as my 3 binary number is gonna be 0011. So my dividend is here as well as my divisor is over here. So over here I am declaring my initial variable as A. So the first register A is equal to 0, which is nothing but you are gonna get a final solution as your reminder part. So here A is gonna be your 0 initial bit, and similarly M is nothing but my divisor part, which means so my count where register is gonna be N is equals to 4 bits. Here my example part is 11 and 3, and here I am declaring my parts, my binary numbers is gonna be 4 bits. So I'm giving representing N should be as N is equal to 4 bits. So when comes N is equal to 4 bits, it should be like my initial reminder value A or A should also be as 5 bits, as well as my M divisor should also be as in 5 bits. If suppose my example part I'm giving my N value as 5, which means that my initial variable A as well as my M divisor should also be plus 1, which means that 6 zeros or else in 6 bits. So here I am giving it as A is equal to here 0 additionally, which means it is a 5 bits, as well as my M value is gonna be 3. I'm just writing here 0011, since because it is 5 bits I'm giving it as the 00011. So we'll come into your problem procedure. So here my first procedure is my initial method according to my flowchart. So I'm giving the condition, the count should gonna be an idle one. My initial operation is gonna be initial method, and over here A is gonna be my 0 values. So which means it is in 5 bits. So it is in 5, as well as my Q is gonna be my dividend over here, dividend which is nothing but 11 is my value of Q. So here it is gonna be 1011. So this is gonna be my initial procedure. So the first step which I'm going to take over here, so N values, since because N value is 4 bits, I'm taking my first count of iteration as 4th iteration. So in my 4th iteration, what is the procedure given over here in the flowchart? So it is a flowchart giving an initial process start and goes on to my initial step, as well as the next step is gonna be shift left of AQ. So over here I am performing my reminder operation A as well as my Q divided as shifting left side of your operation. So over here I am giving it as shift left of AQ, which means giving it as one by one bit over and shifting it over left side. So over here I'm giving it as 000, 0 again, and 1 over here, then again Q 0 1 1. Instead of writing it as 0, I am just giving it as a dash value, as empty value over here. Okay, so while shifting operation it's gonna be like 0 0 0 over here, 0 again, and the previous Q value is gonna be 1 over here, and 0 1 1. Since because it is 5 bits and the other one is going to be in 4 bits, we are giving it as empty value over there. What is the next operation given over here? A is equals to A minus M. So in your binary numbers, before going into my subtraction method, we did not make it little more complicated. So over here we can use your 2's complement operation. So what is my value of M? M value is going to be 00011. So it is easy to identify that if you give your value as minus M, finding a 2's complement, it will be easy for the binary addition operation for my A minus M value. So over here in M I am giving it as taking this part as particular calculation area. So M value is gonna be 000 and 11. Taking out my 1's complement, it is 111 0, 1's complement over here, then 2's complement, giving it as 1 0 111. So this is gonna be my minus M value. So after finding out my minus M value, it will be easy for you to calculate A minus M. So what is my A value given over here? So the first step condition, giving it as 4 zeros and 1. So I'm taking it as 4 zeros 1, and instead of doing as subtracting, I have the value for minus M. So minus M I'm giving it as triple 1, 0, 1. So while adding it, 1 plus 1 is 0, 1, 1, 1, 1, 1. So I'm giving a new value as 1, 1, 1, 1, 0. So where will you store all these things? A minus m is gonna be stored into my A reminder, A initialization value. So I'm writing the value as 4 ones and 0, and the Q step is gonna be the same procedure. I'm writing the operation as A is equals to A minus m. So what is the next procedure given over here? Checking my sign bit of A. So while checking your sign bit of A, which means that you are supposed to check your most significant bit of A operation. So in 5 bits, I am checking the first bit whether it is 1 or 0. If suppose my A value is 1, I am supposed to fill my Q0, which is Q0 is nothing but what the value I am giving over here, a dash, I given a blank, right? So I am supposed to write as Q0 is equal to 0, and the next should be write as restore A. If suppose my sign bit of A value is 0, I am supposed to write as Q0 is equal to 1. So my sign bit is gonna be 1 over here. So from the flowchart we can see that my value should be Q0 is equal to 0 as well as it is restore A. So I'm supposed to write Q0 is equal to 0, and similarly it is restore A. So when Q0 is equal to 0, when Q0 is 0, you're supposed to write as 0, 1, 1. In the blank value, I'm supposed to write it as 0. What about the restore A method? Restore A method is nothing but you are supposed to skip your previous condition, which is A is equal to A minus m. Instead, you are supposed to write restore A means you are supposed to write the previous one condition. So which is 4 zeros and 1. So this is gonna be my fourth iteration. So what is given over here? It is given the procedure as decrement n. After decrement n, it shows that if suppose my n value is 0, I am supposed to stop the condition. But here my n value is 4. For decreasing 4, I get the value as n is equals to 3. So again it goes on to my first step as shift left AQ. So writing a count variable as the next iteration as third iteration. I am writing. So next is your shift left of AQ. So again in shift left of AQ, I'm shifting it out. So it is writing as 000, 1 and 0 over here, and again 110, giving a blank line over here. Then what is the next procedure? Again it is A is equals to A minus m. So what is my procedure right now? We have my minus m value as 11101, and what is my A value over here? It is given as 00010. So the next step you'll be writing 11101, and what is the number given over here? It is 000, then 10. While adding it, you are supposed to get it as full 5 ones. So I am updating all ones, and over here same symbol over here. What is the next operation? Checking your sign bit. So what is the sign bit over here? Over here you have sign bit as A value is 1. So with my sign bit value of A is 1 means you are supposed to write Q0 is equal to 0 and restore A. So write down the operation as Q0 is equal to 0, and similarly restore A. So checking your sign bit over here. So my A value sign bit is 1. So for my flowchart diagram, I am giving it as my sign bit 1, which means it is Q0 is equal to 0 as well as restore A. So Q0 is equal to 0. How we are going to write it as 110. Then again it is 0. Restore A means we are going to be skipping my previous step and going to write the first A value. So it is 000 and 10. So what is the next condition? Decrement my third value. So n is equal to 3 over here. Decrement n, which means it is n, which my 3 minus 1, which is 2. So I'm going on to my second iteration. So what is second iteration again given over here? It is shift left of AQ. So writing it as shift left AQ. So shifting the operation given over here, it is, how will you write it? 0, 0, 1, 0, then again 1 over here. Then how are we going to write a Q value over here? It is 100, then giving a blank value over here. So what is the next step? Next step we're going to do A equals to A minus M. So my A value is going to be 00101. So write here 00101. What is my minus M value? It is going to be 11101. So here 11101. Do your addition operation over here. 1 plus 1 is 0. Again 1. 1 plus 1 is 0. Again 1. 1 0 1 0. Excluding your carrier operation over here, 00010. So where are you going to store over it? Since because it is A equal to A minus 1, it is going to be stored in my A value as 00010. So here Q is going to be written as it is. And the next operation, checking your sign bit operation. So what is again given over here in sign bit of A? Now my sign bit A value is gonna be 0. So what is the operation should I perform? If it is my sign bit value is A equal to 0, which means if the sign bit value is 0, I'm supposed to write, I have to fill the blank condition Q naught as 1. Okay, so I'm writing it as Q naught value as 1. I'm writing the operation over here Q naught equal to 0, and A I'm writing the as it is. Since because while writing a restore A operation, I was skipping the previous condition, writing what A value was given. So since because I don't have A naught Q restore of A, I'm writing the same procedure. What A equal to A minus M is provided. So particular solution is given written over the next one also. So 00010. So this is gonna be my second iteration. So do you think whether it is completed or not? Again checking it with decrement n. Decrement n, whether n is equal to 0? No. So 2 minus 1 goes on to my next iteration as the first iteration. Number 1, what is given over here? It is shift left of AQ. So again it is shift left of AQ. How do you shift the left hand side? I'm writing it as 00010, then 1 value over here, and here it is 001 and giving a blank value. What is the next operation we have to perform? A is equals to A minus M. So writing it as A is equals to A minus M. Supposed to write my minus M condition is over here, and A value is going to be 00101. So write, do the one scope operation over here. Binary addition 00101, as well as my minus M value as 11101, which means it is 1101, 1101, 110 is again 1, 110 is again 1. So carry, I am just excluding that, since because it is a 5-bit value, so I'm writing and excluding the carry value, writing it as 00010. So it is 00010 over here, and the Q operation is gonna be the same thing, 001 and a blank value. What is the next one given over here? Checking your sign bit of A. So what is your sign bit A over here? Since because my sign bit A value is 0, so we are supposed to write my Q naught value condition as 1. So how do you write it? My sign bit value is 0, so writing it as 0, 0, 1, and blank value should be as 1. So here it is Q naught is equals to 1. So my A value is going to be the same thing, 00010. So this is my final condition over here. I am checking with my decrement step. Decrement n is equal decrement n, which means 1 minus 1 is 0, which means n is equals to 0 value. So when it comes at a 0 value, I am checking whether my condition is given correct or not. So A is gonna be a binary number as 00010, which means it represents 2, and similarly my quotient value as 3. So 11 divided by 3, which means that I get the remainder value as 2 as well as my dividend as 3. So finally we'll get the solution as my remainder A is going to be 2 as well as Q value is going to be the same condition which I have started with my value. Q value will be my 3, which is your divisor over here. So divisor 3 as well as my final solution R. So here we'll go on to stopping the condition over here. So this particular example is given for your restoring division. So according to the flowchart diagram, you're going to solve the entire program. One thing is that while doing your initialization operation, goes on to your shift left AQ, and similarly goes on A equal to A minus M. Instead of doing your binary subtraction, we are just giving it as taking 2's complement of M value and writing my binary addition as A minus M. Goes on, check with your sign bit of A operation. If it is 1, I am supposed to go to Q naught equal to 0 and restore A, as well as when it is Q naught is equal to 0, it goes as Q naught is equals to 1. Then finally decrement N and N is equal to. So when my condition N is equal to 0, we are supposed to stop the condition. So that is one small hint to complete this particular restoring division method. So one small hint is nothing but, while giving your division part, your example problem, if your binary, if your giving question is binary number is like 4 digits, suppose the given question is 11 divided by 3 or some other number which the binary number is 4, my count register N is equal to 4, so the entire iteration will be in 4 steps. So you complete the particular procedure in within 4 steps also. If suppose my count register is in 5 bit number, and my N value is 5, until the fifth iteration my procedure will go on, and the last thing I will get the solution of my remainder value as well as my divisor. So these are all the example condition for your restoring division part. So all the best for your next exams. So the next topic is about your, in your division part you have 2 parts. One is your restoring division and the other one was your non-restoring division. So the previous was restoring. When it comes under your non-restoring division part, there are same procedure which compared to your restoring method. Only thing is that there are few changes in your flowchart method. So the way you're gonna proceed it and the way you're gonna divide the condition over here. So in non-restoring division part, we'll go on to your first thing, your flowchart condition. So in your flowchart method, giving in a start condition, the initial procedure as A is equal to 0, and similarly my M value is gonna be my divisor and N value was count, and similarly Q is gonna be my quotient method. So this is gonna be the previous 4 registers, and the 4 register, one is your A value, and similarly M is your second register, and N is your number of count registers, and similarly Q is gonna be a quotient. So until completing these 4 types of register, we'll go on to your checking a condition as sign bit of condition. So in previous restoring method, we are looking at here the procedure was shift left of AQ operation, and the next was about your A is equal to A minus M. Then last procedure will be checking your sign bit of A. But in the non-restoring part, the first procedure is that after initialization part, you are going to give your checking your sign bit condition. So here my sign bit of A I am checking a condition. If it is 1, I am supposed to do my operation as shift left of AQ operation, and the next is A is equals to A plus M operation. If suppose my A sign bit value is 0, it should be given as my shift left AQ operation, and the next is A is equals to A minus M. So this is going to be my after initialization procedure. This is going to be the next step of identifying the sign bit of A condition, whether if it is 1, so simultaneously you are supposed to perform shift left AQ. One thing is that if it is 1, you are supposed to do as A plus M, whether if it is in 0, you are supposed to write A is equals to A minus M. Going on to the next condition, you are supposed to again check your sign bit of condition A, which is if it is A condition is 1, you are supposed to write my Q naught is equal to 0, and the 0, if suppose the value is 0, I am supposed to write my Q naught value as 1. So in the previous thing, restoring method, you are supposed to write as q naught is equal to 0 and restore a. Here we are not going to restore. That is why the title is given as non-restoring division. So without restoring the previous a condition, how we are going to completely solve your particular program. So here doing your sign bit condition as a value 1. If it is 1, you are supposed to write as q naught is equal to 0, and if it is 0, you are supposed to write q naught value as 1. So goes on to my decrement procedure. So how many number of registers are there? So in the count value, my n value will be decrementing 1 by 1, and the next condition is given as n is equal to 0. So previous thing, until we complete our n is equal to 0 operation, we will be stopping the condition. One small change is that in doing a n is equal to 0 condition, if suppose the condition is satisfied, we are supposed to check your sign bit value a, whether the sign bit of a value is 1, you are supposed to do as a equal to a plus. If it is 0, I am supposed to stop the condition. Or else, if it is n is equal to 0, it doesn't satisfy, we are supposed to go on, start with your sign bit procedure. The same shift left operation, and the next a plus m or else a minus m goes on to my q naught value as well as my q1 value. So it will be going on, and similarly last we will be checking your sign bit value. If doesn't satisfy a value as 1, I am supposed to find out as a equal to a plus m and stop the condition. So this is going to be your workflow of your non-restoring division part. So without restoring, how we are going to solve the entire program. So we are going to take the same example as 11 divided by 3. As I said earlier, if it is 11 and it is 1011 and 3 as 0011, here again your count register n value is going to be 4, which means my initialization value a is going to be in 5 bits. So which means it is 5 zeros, as well as my m value, which is 3, is going to be represented in 5 bits. So I am writing it as a value will be in 5 zeros, as well as my 3 is going to be written in m value as 00011 as my m value. So we do have your a minus m operation. So we are gonna priorly we are gonna write it as find out your 2's complement and find out your m condition. Over here minus m is nothing but your 000 and 11. You're writing over here, find out your 1's complement, 111 0 0, and doing a 2's complement I'm getting it as 1 0 1 1 1. So this is gonna be my minus m condition. So before going into my problem condition, it will be easier whether if you suppose you're priorly finding out your minus m value when providing other solutions, it will be easier to identify. So the next procedure is that you can finally condition as initial operation. So in your initial operation, you're supposed to identify the first value. My a value is gonna be zeros for all 5 zeros, and similarly my q value is gonna be represented as 1011. So this is my initial procedure. So what is the step given over here? Because my n is gonna be a 4-bit operation, so I'm gonna start with my 4th iteration over here. So in my 4th iteration, I'm just going to find out whether the first condition is given as check your sign bit of a, whether it is 1 or a 0. So my a sign bit value over here, it is represented as 0. So which means if it is 0, what should I perform? It shows that shift left AQ operation, and the next as a minus m operation. So here I'm writing it as again shift left of AQ operation. So which means how do you do your left shift operation over here? 0000 and 1 over here, writing it as 0 1 1 and giving it blank. Same restoring part, the same procedure is going to happen over here. And what is the next condition given over here? If it is my sign bit is 0, I'm supposed to do my shift left operation and goes on to my a is equals to A minus M procedure. So what do you do for A minus M procedure? You are supposed to do your subtraction. So instead of doing a subtraction method, you go on to your 2's complement method for minus M. So already I find out my minus M method. So what is the A value given over here? It is going to be 00001. So I'm going to solve it 00001, and minus M operation is going to be 111 and 01. So what is given over here? 1 plus 1 is 0. Then again 1 over here, 1, 1, 1, 1. So this is going to be my A value, 11110. So Q value is going to be the same thing, 0110. So what is the next condition given over here? Again, I'm supposed to check my sign bit of A value. So here my A value sign bit is 1 given over here. So which means what is the procedure? If it is 0, I'm supposed to write the blank condition Q naught is equals to 1. If it is 1, I'm supposed to write Q naught as 0. So which means, so what is given over here? Because my sign bit of A value is 1, I'm supposed to write Q naught is equals to 0, which means in Q value I'm supposed to write 0, 1, 1. With the bank value I'm supposed to write as 0. And similarly the next A condition is going to be the same. We are not going to do any restoring operation, so that the previous A value will be the same thing over here. So what is the next method? What is the next procedure in your flow chart? It is given as N is equal to N minus M. N minus 1 means, which is like 4 minus 1 is nothing but 3. I'm going on to my third iteration over here. What is given again? Again check your sign bit value. So while doing a sign bit checking value, what is the value given over here? It is given as 1. So sign bit of 1, which means shows that shift left of AQ as well as A equal to A plus M. So here when it goes on shift left of AQ, then how do you identify the shift left of operation? So you're going to skip this particular number as 1 and write as 1, 1, 1, 0. Then over here 0 value, and similarly 110. Put a blank line over here. What is the next condition? A is equals to A plus M. So in your A is equal to A plus M, what the value you are going to take? A value is given as 11100. What about my AM value? We are not supposed to take minus M. We have already got from the question AM value was 00011. So here students make it mistake as while identifying your minus M as well as M condition. So when the procedure is given as A plus M, you are supposed to take your M value from the question. If it is given as minus M, you are supposed to take only your 2's complement value. So which means my A value, A plus M, over here A value is going to be 111 and 00. What is my M value? It is 00011. So while adding it, I'll get as all 5 ones. So all 5 ones will be written in your A value. So all 5 ones, and over here Q is gonna be the same thing. What is the next procedure? You are supposed to find your sign bit of A value. So again your sign bit of A value is 1 over here. So if it is 1, you are supposed to write your Q naught value as 0. So your Q naught value, Q naught is equal to 0. You will be writing it as 110. Then your blank line, you will be writing it as 0, and your A value condition is gonna be the same. Because there is no restoring method, you're not going to write the previous one. Whatever we are writing it, you're supposed to write in a step-by-step procedure. Hope you're all understanding these step-by-step condition. So what is the next method given over here? So what is the next method? It is given as 3 values. So because n is equal to 3, you are supposed to decrement the procedure, which means is 3 minus 1 as 2. So I'm getting it as a second iteration. So again goes on to my sign bit checking value. So what is the sign bit checking value given over here? It is 1. So because it is 1, you are supposed to perform your shift left of AQ as well as A is equals to A plus M. So which means I'm doing operation as shift left AQ. So we're doing a shift left AQ, you're going to skip this number, doing a shift left shifting operation and doing 4 ones and a 1 over from here and 1 0 0, giving a blank line over here. What is the next operation? A is equals to A plus M. So when it's A plus M, you're taking as all 5 ones. And what is my M value? My M value from the question, 000 11. So here 1 plus 1 is 0, again 1 plus 1 is 0, carry 1, then 1 carry is over here, again it's supposed to write as 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, you can ignore this particular carry, so you can write it as 00010. So while performing your binary addition operation, you are supposed to be very sure with your addition operation. If it is in 3 numbers of adding, you are supposed to guide. Mainly students make a particular mistake in adding these binary numbers. So your Q value is going to be the same thing, 100, and the next one you are going to condition as, say, finding your sign bit value of A. By writing a sign bit value of A, then again it is 0. So if it is 0, what should I write? It should be like Q naught value as 1. Q naught is equals to 1, which means 100. The blank line is going to be as 1 and my A value will be written as it is. So then what is the next condition? Giving a decrement value, 2 minus 1 is 1. So going on to the last iteration method as 1. I'm writing condition, sign bit of value A. So checking the condition whether if it is 0, 1, if it is 0, I'm supposed to perform shift left of AQ operation as well as my A minus M operation. So again I'm performing my shift left AQ. So again I'm going to shift the left operation, double 0, and should be 1 0 1 0 1, giving it a blank. And what is the next value given over here? A is equals to A minus M. So here my A value is going to be 00101. Your 00101. What about your minus M value given over here? It is 11101. So here it is 11101. While adding this condition, you are supposed to 1 plus 1 0, 1, 1 plus 1 0 is carry 1, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1. So you can ignore this one and write it as 000 and 10. So writing it as 00010, and my Q value is as it is. What is the next condition given over here? Finding out my sign bit value. When the sign bit value is 0, what should we supposed to do? Q naught should be 1. So writing it as Q naught is equals to 1, which means I'm giving the condition as 0 0 0 1 0, and my 0 0 1, the blank value will be given as 1. So this is the entire step condition over here. Going on to the next condition as n minus 1, which comes as 1 minus 1 is 0. So you're gonna skip this condition. When it comes to n is equal to 0, the condition is satisfied, and goes on to check my sign bit condition of A value. Since because my A value is 0, I am stopping my condition, so I could find the correct answer. So 11 divided by 3, my remainder part should be 2, as well as my quotient Q value, that is my dividend, should be as 3. So finally I got the solution as 2 as well as my dividend as 3. Since if suppose I get the answer sign bit of value as 1, I'm supposed to do again an operation of A is equal to A plus M, and finally complete your solution. This particular procedure is for your non-restoring division. So when comes under your restoring part, you will be doing only a shift left or AQ operation, and goes on to your A equal to A minus M, and finally checking your sign bit value. Whereas and in between you will restore your A value in between your your q naught while declaring your q naught is equal to 0. When comes into your non-restoring part, we are going to skip the restoring part and goes on to your 2 times we are going to check your sign bit value. So sign bit value, initial condition shift left AQ as well as A minus M and A plus M, and the next sign bit value you are going to place it as Q naught equal to 0 as well as Q naught equal to 1. So this is the entire procedure for identifying your non-restoring division part. So in your non-restoring division part, this is the entire complete procedure. So we'll quick recap for your particular division method. So in your previous thing was about your restoring division, the same procedure, the same question was given. One small hint is nothing but if it is a given question value is in 4 bits, your entire procedure, entire problem will be solved in your until 4 iterations. If suppose if you are taking it as a 5 bits, and the entire procedure will be solving in your 5 iterations. In 5 it will be completing. So all one thing is that there will be small difference in your flowchart condition. If it is in restoring method, a simple method of restoring condition, only 2 procedures in between of shift left AQ and A is equal to A minus M, and then next goes on to your sign bit of A value. When it comes under your non-restoring division part, you will be having 2 sign bit of checking method. One will be checking for sign bit value whether it should be solved in A equal to A minus M or A plus M, and the next sign bit value I am checking as Q naught is equal to 0 as well as Q naught is equal to 1. Finally we will be solving the condition. So the entire procedure will be finding it out in question last 11 divided by 3, giving the procedures count A and Q and operation. You are initializing with your 4th iteration n is equal to 4, and A value I am giving it as my initial condition shift left AQ operation. Shift lefting of AQ operation, you are going to skip the 0 condition, write the 4 zeros, 1 over here, and similarly 0 1 1 and putting as a blank line, and A is equals to A minus M, the entire condition. So by starting your particular problem, you can write it as find out a M value as well as your 2's complement minus M value, and then start solving the entire procedure using your A minus M condition. Then finally again check your sign bit value, as if it is find it as 1, you are supposed to write Q naught value as 0. So this is the entire procedure for your non-restoring division part. So hopefully you would have understand the entire concept of your restoring division part as well as your non-restoring division part. So all the best for your exams.